Thank you so much. And thank you for joining. You know, just to get a sense of the room, if you can raise your hand if you are currently in the process of or have completed a machine learning project at your organization. Okay, all right. So no matter what the experience level, I've tried my best to incorporate content so you will walk away with something useful and some valuable insights. And the way we're going to do this is I'm going to set the context and define some terminology around machine learning, and then we'll get into some of the insights that we've gained over the years. And so first of all, a little bit about myself. My name is Ahmed. I'm a solutions architect at Amazon Web Services. I've been with AWS for over 4 years and have helped multiple companies migrate to the cloud and also implement machine learning solutions as well. I focus on our machine learning portfolio of machine learning services. So back in 2013, a tweet came out of the Associated Press that talked about a couple of explosions in the White House. Obviously, the Twitter account was hacked. But within seconds, the Dow plunges 140 points, and there is a, tens of billions of dollars are lost and regained within a matter of seconds. So what happened here? Obviously, automated trading. So trading bots that are looking at text within social media, within earnings calls for companies, and obviously Twitter accounts. And so the reason why there was a flash crash was this was being adopted widely on Wall Street. It wasn't just one or two companies doing this. And this is back in 2013. 2014, we launched the Alexa personal assistants. There are other personal assistants that came out too. And so people really felt the exponential increase in not only the voice recognition capability, but also the ability for these devices to really decipher meaning out of what was being said. So they were not just able to convert speech into text very accurately, but also they were able to decipher meaning out of it. And just recently, just last year, this research came out of Stanford that said, hey, we have algorithms now that can look at chest x-rays and diagnose pneumonia better than radiologists. And so what is behind all of this? Tremendous increase, exponential, giant leap in technology, right? So let's look at that. What made it possible? If we look at the Twitter AP flash crash, obviously it was trading bots that were doing sentiment analysis. The sentiment analysis is done by a type of a technology called deep learning. Amazon Alexa is doing automatic speech recognition, ASR, combined with natural language understanding, NLU. And sorry if I have a lot of terminology here. I'll explain some of this in upcoming slides. So the ASR and NLU is enabled by a type of deep learning that uses recurrent neural networks. And then we have Stanford pneumonia diagnosis algorithm that's using image recognition that's enabled by convolutional neural networks and deep learning. And everything here is being enabled by machine learning. And all of these different types of solutions, enhancements, are because there have been improvements in machine learning in the recent years. And so it's super important to identify these terms and make sure that we understand the difference between these terms and This is a nice graphist that obviously I took from somewhere, but people people use these terms interchangeably, right? They'll say machine learning, they'll say artificial intelligence. AI is the broad field where in computer science and artificial intelligence, we try to mimic the human intellect by different algorithms. And within that field of artificial intelligence, we have the subfield of machine learning, which uses historical data to make predictions about current data or to solve all sorts of problems, right? And within that realm of machine learning is this field of deep learning where there's been a lot of excitement in the recent years and a lot of enhancements in the algorithms. And deep learning is nothing more than a bigger neural network. And neural networks are basically this data structure that's been used for decades, but there have been some enhancements in the recent years that I'll talk about that have really enabled the use of deep learning and neural networks. Another area that we should know about is supervised versus unsupervised learning. And so within the realm of machine learning, you have supervised learning and unsupervised. And the difference between them is in machine learning, you have to have historical data, right? In supervised learning, for example, if you focus on the example on the left, what we are trying to do is predict the price of a house. Right? Based on the number of bedrooms, the bathrooms, square footage, obviously there will be other attributes like zip code and whatnot that will determine the price of the house, right? And so if that is your historical data and you have historical prices at which the houses were bought and sold, then in machine learning, the beds, the bathrooms, and the square footage of the house are features that are given to you, right? And then you also have the price of the historical price of houses, which is your label, right? And what you're trying to do is train a model that can look at this historical data, and then once it's trained, you can just input the features and you'll get the label out, which is the target that you're trying to get to, right? And so that's supervised. Unsupervised is where you only have the features and you don't really have a label defined. And what you're trying to do is maybe do cluster analysis. So one of the examples in unsupervised learning is using clustering algorithms to do customer segmentation. And so, if you're selling to a broad audience and you want to see which demographic segments are buying your things, and so you can take your sale history and apply k-means clustering algorithms to understand what are the patterns there. And you really don't need to identify any label there. All you do is feed in the features, the historical features, and the algorithm is able to do the clustering or grouping and identify insights within the data. A deep neural network, I'm not going to go into too much depth, but whenever we talk about it, people think it's super complicated. It's it's trying to mimic the brain very crudely, and the key term here is it's trying to mimic it very crudely. It's nowhere near a human brain. What separates a neural network from a deep neural network or deep learning that enables deep learning is just the hidden layers. So in this example, it's a very simple multi-layer perceptron that has 4 layers. There's one input layer on the left and another output layer on the right, and then you've got the 2 hidden layers in between. And so a neural network that has 2 or more hidden layers is a deep neural network. So if you're using a neural network that has more than 2 or more hidden layers, then you're doing deep learning, essentially. So nothing super complicated about these terminologies. Another cool area within machine learning is that of reinforcement learning. So you might have heard of Google DeepMind's AlphaGo, and there are other agents out there, machine learning agents, that can play video games. And so we'll take an example of, let's say, an AI agent that's playing the classic Atari Pong game, right? And so in that scenario, the agent is obviously our machine learning agent, and the environment is the video game, right? And the video game has a state, where the bar is and where the ball is, and also the score of the video game, right? And so the way it works is, at a very high level, the environment provides the agent with a state. The state obviously contains the position of the bar, the position of the ball at any given instance, and the score itself, right? And the agent is taking an action, and based on that action, obviously the state of the environment changes. So in the video game example, the state will change, right? Maybe the algorithm is able to deflect the ball, and the opponent misses the ball, and then the state changes. The algorithm gains 1 point. And so that point or the score becomes the reward, and also is part of the next state, right? And so we do this iteratively over millions of iteration. And what comes out is this agent that has gained the capability, has self-learned how to play Pong. And so this is a very exciting area, although this is really cutting edge right now, and I feel like there are a few experimental frameworks out there that enable this, but this is mostly in academia right now, and it's a research topic. So let's also talk about how is machine learning different from traditional programming, right? This is a developer conference. Obviously, I come from a development background as well. Traditional programming, the developer programmer develops an algorithm. You have some kind of data in a database, data store, data warehouse, and that algorithm acts on that, and you get some kind of output, right? That's the traditional computer science programming model, right? In machine learning, it's a little bit different, right? So the way it's different is now the developer or the data scientist is writing a program, but that's a training algorithm, right? It's acting on historical data, and what is being output is a model, is a machine learning model. And then you take that model and you feed current data, and you can get predictions out of it. So a little bit different process there. And so now you might be wondering, like, why is this happening now? Neural networks, as I've mentioned, have been around for decades. Why now? So the quick answer is there are 3 factors. There have been a lot of improvements in algorithms. If you go into neural networks or deep learning, there have been improvements in the algorithms coming out of academia. Secondly, hardware, obviously, with capabilities like GPUs, we can do mathematical operations very, very quickly. Cloud computing has accelerated not only the hardware aspect, but also the data storage aspect. And now the companies have been storing data for the past 2 or 3 decades, right? And so I feel like that is really key here, because now you have the data. And if you think about it from your company's or your organization's perspective, you and your competitors are probably gonna have the same access to the same algorithms, and you're gonna have the same access to really fast, cheap hardware, on premise or in the cloud or wherever, right? But what makes you unique is the data that you have, right? So data is super important, and it becomes really important when you consider this. And so there were traditional machine learning algorithms that were, linear regression, that were based in statistics. And what happened was you gave that algorithm some historical data, right? And that improved the accuracy, but up to a point, right? And then it plateaued, and that was it. But with deep learning techniques, what's different about deep learning is the more data you give it, the better it becomes, right? And so data is really key. So that leads us to our insight number 1, which is data is gold. If you are storing data about your customers, about their usage patterns, buying patterns, and whatnot, store the data, right? Obviously, it goes both ways. There have been recent examples of malicious use of this as well, right? But data is super important. Not only big data, but data that is wide. So not only a lot of examples, but the more attributes you can get, the better your results or the better the insights, right? And so when we talk to our customers, some of them will say, hey, we want to automate everything. Machine learning is just going to automate everything. And when you get into the weeds of that's really not true. Ask Elon Musk, right? Not totally related to machine learning, but there is such a thing as over-automation, right? You've probably come across an AI agent or a chatbot agent that's trying to be human, and it's not a good user experience, right? And so whenever you're making that decision at the outset where you're looking at a problem, whether to automate it, using machine learning or not, you have to consider this factor that, hey, is it a repeat problem that I'm going to face repeatedly? And secondly, obviously, when you consider machine learning, you'll need a lot of historical data. And do I have the historical data here, right? And so humans are, at this point, still they learn very quickly, and machines are slow to learn over time. And plus, with time, obviously, productivity of machines cannot be matched. So that leads us to insight number 2. Pay attention to automation versus augmentation. Not every problem is suited for machine learning, right? You have to ask that question: do I have a data? Is it a problem that I'm going to face repeatedly, right? And in a lot of situations, we see that a hybrid human / AI hybrid solution is really the best user experience. I was talking to a startup recently that's working on providing nutritional coaching over chat and whatnot, chat and voice as well. And their main method of communication is this chatbot that's powered by AI, right? But they do have a mechanism when their customers are not feeling good or they're not happy with the service, that they have to have a mechanism to bring in a human into the communication chain, right? So super important to consider that. Then with the rise of the personal assistants, the Alexas, Watson series of the world, people think that, hey, these things can answer everything, right? So maybe I can take Watson or Alexa and connect it to my data that I have at my organization, and it will just learn everything, and which is not true. And so there's no general purpose intelligence, really. You have to really define the scope of the problem that you're trying to solve, right? What is it? Why is my customer trying to call me? My customer's uploaded this image. What is in that image, right? If a customer is browsing on my site, when is this customer going to likely to make a purchase, right? So these are the kind of questions that you have to really think about, that you have to scope the problem, right? There's no automatic learning. A couple of years back, Microsoft released a chatbot that was supposed to look at Twitter feeds, and very quickly it became very nasty, right? And obviously, if you have followed conversations that around any controversial topic, around politics or religion, they tend to get very nasty very quickly on public forums such as Twitter. And so the insight, they had to shut it down. The insight here is data quality really matters. If you're feeding the algorithm garbage, you're gonna get garbage out of it, right? And the data that you're collecting needs to have learnable attributes, right? And if we go back to the housing example, we know that the number of bedrooms, bathrooms, square footage, zip code really affects the price of the house, right? If you took some random data and made that part of the data set, it's only going to confuse your machine learning algorithm, right? So data quality is super important. So another one that our customers talk about is, I am a small shop. There's no way I can gather as much data as Amazon or Google or some of the big guys, so might as well not try, right? Which is so not true. Yes, you might not have access to a lot of data, and obviously data is super important, as we mentioned. But there are techniques out there where you can really stand on the shoulder of giants. There are available data sets out there that are publicly, freely available of charge, right? And even if you have a small data set, you can use techniques like fine-tuning and transfer learning in deep machine learning, deep learning, where you can actually take some of the pre-trained models and include those learnings into your machine learning model, and then fine-tune it to your use case with your small data set. So really, there are examples for, let's say you're trying to do some image recognition in the healthcare space, right? And you're trying to get insight. I was just talking to someone who was trying to do recognizing images, was trying to scan a medical insurance card, right? Very specific. But what you can use is pre-trained model like ResNet, VGG, or Inception, and really take that, include that into your custom model, and that becomes, and so your small data set can very quickly yield very good results now. When it comes to natural language understanding, NLP and NLU, you can use pre-trained word embeddings like Word2Vec or Glove from Stanford. When we think about the machine learning lifecycle, this is usually how it goes. You have some data set, you do some data exploration, do some feature engineering, and then you go build your model, you train and do inferences, evaluate the results, and do this iteratively to keep improving the model, right? And a lot of people pay attention to the bottom three ones, especially the building and training piece, right? But they don't pay attention to data exploration and feature engineering. And that's really our insight number 6, is feature engineering is key, right? So look for attributes that are going to make your data more valuable to the algorithm that you're using, right? A quick, simple example. Well, first of all, in neural networks, everything needs to be converted to numbers. So it's super important how, and give a lot of attention, pay attention to how you're converting your data into the appropriate numbers that represent your data to be fed into the neural networks, right? An example is predicting seasonal sales, where you have some historical sales data, and as part of that, there's a timestamp. Now, the timestamp is pretty much like a random string for the machine learning algorithms, but what you can do is divide that into 2 features, right? Where you get time of the day, and then perhaps you divide it into the fall season. And so now you're giving the algorithm the ability to detect seasonal change, right? And so maybe you have a business where the sales are really seasonal, so you'll be able to detect that, right? So now you're at a point where you say, okay, yeah, I wanna use machine learning for my business. So where should I start? Like, should I go for a custom model, or should I just use one of the generic APIs? Like, we have a lot of APIs at AWS for AI. So where should I go about, and what should I do? So there's that question of build versus buy, right? And the way we see our customers, we really see that most of our customers that are on AWS belong in this long tail where machine learning is not really their core competency, and so they're better off using general purpose APIs, right? Then there'll be people that have a lot of data, the specific historical data for their business. And that's where the BYOM really stands for bring your own model. And so that's where it makes sense for you to invest in building a custom model for your problem. And so an example would be predicting customer behavior. Obviously, it's your customers. They're looking at buying patterns for your business. And if you're trying to predict that customer buying behavior, definitely want to invest in a custom model, right? Another example for the general purpose API is like, let's say you're trying to do sentiment analysis. You're better off, rather than doing a custom model, you're better off using a higher level API that does customer sentiment, right? And then there'll be use cases which are very appropriate for vertical partner. For example, some company that is focused, or startup that's focused on doing machine learning for the healthcare space or for the finance space. Obviously, there's a huge market for that as well. So I'm going to put in a shameless plug for AWS at this point, right? So we've got a whole bunch of higher level APIs, and we've got a platform service called Amazon SageMaker that lets you create, build, deploy, and iterate on custom machine learning models. But if you want to use higher level APIs for voice, text, video, chatbots, translation, we have all of those available as higher level APIs. We also have, obviously the infrastructure is available for, we have NVIDIA GPU enabled instances, and we support most of the widely used deep learning frameworks as well. So this is, so that leads us into, build versus buy. Number 7, definitely, just recapping this, definitely start looking at Cloud API. It's quick to get started on. You don't have to invest a lot of time in learning about machine learning. But really, the main question here is, if you have a lot of historical data, then you definitely want to invest in not only learning about machine learning, but also developing that custom model that can give you the insights and give you a competitive edge over your competition. Okay, now you're sold on. If you're sold on machine learning, how do I go about this, right? Which programming language, deep learning framework should I invest in learning? This is a great time to get into this, right? These are some of the major frameworks. The leading ones, I believe, that have the biggest community are TensorFlow and Keras. And if you're just getting started, I would highly recommend Keras. That is now part of the standard distribution of TensorFlow. It's just easy. And I think with time, it'll become easier and easier for typical developers to start using machine learning, and it'll become another tool in their toolkit, right? So something to consider, definitely look at higher level frameworks such as Keras, Gluon, PyTorch. Those are good, and look at the languages that they support and how big of a community there is. It's very likely somebody is already trying to solve the problem you're trying to solve, so you'll get a lot of starter code and help from the community as well. Another one is, we're a small shop. We can't really hire some of the PhDs. Some of these machine learning experts and data scientists that are coming out with PhDs are obviously, the area is hot, and so they're super coveted and highly paid, and not every business can afford them. There's an answer for this. This is, this time right now, I feel like it's changing so quickly in the last even 18 months. If you were starting about 18 months ago, you had to consider, really like a steep learning curve with some of these deep learning frameworks such as TensorFlow, and think about new ways of developing data structures if you're a programmer. But like with the advent of the higher level frameworks such as Keras, I think it's going to become super easy. So consider retraining your developers. Obviously, developers that have a background in math and science are probably going to be the best resources for this, right? And then finally, at Amazon, one of our leadership principles is learn and be curious. You know, it's amazing how many free resources there are out there at this point. If you want to get started, I highly recommend Andrew Ng's deep learning course on Coursera. I think it's still free, and you can definitely take it and go through and do the exercises. It's one of the best resources and best classes that I've taken. And definitely fast.ai, hands-on training. And then we have, as part of our deep learning framework called MXNet, we have a great resource, the Straight Dope, which is available at gluon.mxnet.io. So with that, that's all I had. I'll open it up for any questions that you might have.
Is there any question?
Any questions? All right, cool.